Today I would like to present a study witnessing title, Using Eye Tracking Data for Weakly Supervised Object Detection. This is my outline. Object detection has always been the most basic and important task in computer vision. The so-called object detection refers to the use of bounding boxes to select objects from input videos or pictures and identify their categories. To train an object detector, we need the location information of the object and its corresponding labels. However, pixel-level or instance-level labeling requires a lot of human resources. In addition, standard assistance in professional fields requires additional costs. Cost to hire experts. Many training samples that are not fully qualified will become unusable. In order to solve this problem, weakly supervised learning was proposed. Next, let's take a look at eye tracking technology. Eye tracking is a technology that allows computers or other devices to record where people are looking. We can use these records to understand what or where people are interested, and then make more use of it. Next are some forms of our expression and analysis of eye movement data. The eye tracker will record a lot of information. What forms should we use to observe will greatly affect the aspect of the analysis. In this paper, we mainly use fixations, heat maps, and area of interest, AOI, to analyze. Object detection with deep learning can be mainly divided into two types: region proposal-based methods and regression or classification methods. Next is an overview of the entire system. First, we use the eye tracker to collect and record the original eye movement data, and then use the analysis software to generate heat maps and fixations. We can use the analysis software to limit and plan out the data we need. Heat maps are used to observe the distribution, and the fixations are used as the input of the intermediate fixation to bounding box module. In this module, the fixation is converted to the candidate bounding box and the image level class label is used as the final object detector YOLOV3 training benchmark. For the analysis software, we use the Chrome Plus record written by Yajing in our laboratory. It is an open-source Chrome extension application. Not only can he be responsible for performance record-related tasks, such as calibration and archiving, but also use your own define the required modules to record the data you need in different categories. For example, this module in the figure has the most basic content of record fixations. We output these data as a CSV file and can be used directly in the next step. It is an extension of Chrome. We can easily complete the experiment on the web page, which is very convenient. Next is the method of turning fixations into bounding boxes. We mainly refer to the method of this paper. He defines this problem as a segmentation problem. First, in the first stage, the picture is processed into superpixel form, and then these superpixels are used. The relationship between fixation and fixation calculates several kinds of features. These features are combined with SVM to create a segmentation mask to classify which places belong to objects and which ones are not. Among them, a small part of the dataset, about 20 per category, Zhang, manually mark the bounding box to train the SVM. The second stage uses the grab-cut algorithm to combine the foreground and background 2GMMs to make refinement. The final result is a segmentation containing the largest connected unit. Our framework provides a convenient way to quickly label massive training data reliably due to the ability of directly using eye tracking data. All you need is to set the eye tracker well, and the subjects only need to see. It can be applied in many aspects, such as advertising video, teaching materials, or even physically challenged related works. Training model with eye tracking data greatly saves time from collecting samples, makes training samples easier to use. Imagine that people watch a movie or take online video courses. Simultaneously, the eye tracking data can be collected and the model can be trained. Convenience of quickly collecting training samples is another advantage our framework has. In this thesis, we propose a framework that integrates eye tracking data and YOLOV3 object detector to fill up the location information loss in weekly supervised object detection problem. We use eye tracker, analytic software, and POET dataset to collect and provide the eye tracking data. Using the features extracted from the eye tracking data to train a segmentation mask that helping us to emphasize the objects in the images, then refine them into bounding boxes. The bounding boxes and the image level class labels are finally used to train the YOLOV3 model.